Welcome back to our channel where we simplify programming challenges and explore different techniques to solve them. In today's video, we are going to tackle a common problem, moving all zeros to the end of an array while maintaining the order of non-zero element. I will walk through not just one but multiple approaches to solve this problem. Whether you are prepping for interviews or just leveling up your coding skills, this video is for you. So, without further ado, let's get jumping. Alright, let's get the problem straight. Where given an array like 35004, we need to move the all zeros to the end while keeping the relative order of non-zero elements. So our output should be like this 35400. The catch is we have to do this in place, meaning we can't use extra arrays and we want to do it efficiently. The expected time complexity is order of n and the space complexity is order of 1. Sounds tricky. Don't worry, let's break it down. Okay, here our first approach is two-pointer technique and it's one of the most efficient solution. Here's the idea, we maintain two-pointer. Okay. um, we maintain two-pointer, one is I, another is j. One pointer I traverse the entire array. Another pointer j to track where the next non-zero element should be placed. Another pointer, this is I and this is j to track the where the other non-zero element is located. So as we go through the array, every time we find a non-zero element, we swap it with the element at index j. Then we increment j to the point to the next available position. This way, all non-zero elements are pushed to the front and zeros naturally get moved to the end. Okay, let's walk through an example. Um, the array is given 35004. Initially, I and j are both the start of 0. As we iterate, the first element 3 is 3, so we swap it to itself j, moves to the next index 5. The second element is 5, same story, swap it itself with and move to j. Then we encounter zeros, So nothing happens until we find a non-zero element again, which is 4. Now we swap the 4 with the first we found and boom the zeros at the end. Okay, let's try to code. First approach, two-pointer technique. Pointer to track the next position of 0 element. So I initialize j as 0. I have to traverse the array. So int I equal to 0, I less than array dot length. Then I increment the I. So this, if the current element is non-zero, swap it with the next element at j. So if array of I not equal to 0 means I use temporary variable in temp equal to array of I. Store the array of I value and I swap it with array of I equal to array of j. Okay, sorry. Array of j equal to stored in temporary variable. Then I increment the j. Okay. This approach gives us time complexity of order of n and space complexity of order of 1 since we are only using the original array. Okay, now let's look at another technique. It's not as elegant as the two pointer method, but it gets the job done. In this approach, we first traverse the array and shift all non-zero elements. First, we have to traverse the array and shift all non-zero elements to the front. Once all non-zero elements are moved, we fill the remaining position with zeros. Okay, we use single pointer j. Just like before, we iterate over the array and every time we find a non-zero element, we place it at index j and increment j. We iterate over the array and every time we find a non-zero element, we place it at index j and increment the j value. After the loop finishes, all non-zero elements are the beginning of the array. Then we simplify, run another loop from j to the end of the array, filling those parts with 0. Okay, here taking the same array 35004. After the first pass, we get 3544. 35444. The second loop fills the rest with zeros. 35400. The output comes. The job done. Okay. For this we have to code. Static void. Okay. Pointer to place the non-zero element. So I initialize j as 0. We have to write the code for first pass. Shift all non-zero elements to the front. So I use for loop I and I equal to 0, I less than array dot length. Next I increment the I value. If array of I not equal to 0, array of j plus plus, I increment the j value equal to array of I. Another for loop for second pass. For what is the second pass method means fill the rest of the array with zeros. J less than array dot length. Array of j plus plus equal to 0. Okay. While this approach works, oh, it shows some error. Okay, here the mistake I use for loop. Instead of I use while loop now. Okay, while this approach works, it's not a intuitive as two-pointer technique, but it's still order of n in time, order of 1 in space. Okay, for our final approach, we could use a simple zero counting technique. This approach is a bit more brute force but still interesting. Okay, so here what do we do? What do we do means we have to done two things. Traverse the array and count the number of zeros. Build a new array by adding all non-zero elements first and then append the number of zeros we counted. But here's the downside. While it is easy to understand, it requires extra space because we end up using another array to store the result. That's why this technique does not meet our in-place constraints. Okay, for this approach, we try to code. Okay, public static void. Okay. I created new array to store the result. And result equal to new int array dot length. Pointer to place non-zero element. Okay. First pass. We have to collect all non-zero elements so that int I equal to 0, I less than array dot, okay, sorry, length, then I increment the I. Okay, wow. If array of I not equal to 0 means I have to add in result. Okay. Okay. Next, I use another for loop to copy the result back to the original array. So I use for loop for int I equal to 0, I less than array dot length I plus plus array of, oh sorry, array of I equal to append to result, list of result of I. Okay. Uh, so here I missed the C, so the errors came. Okay, and there you have it. We have explored three different techniques to move all zeros to the end of an array. Two-pointer technique, efficient and simple. The shift and fill method, clear and easy to implement. The zero counting technique, great for understanding brute force approaches, but not as efficient in terms of space. If you are looking for the most efficient solution in terms of both time and space, the two-pointer method is your best bet. So you go ahead and try these techniques in your own coding practice. If you enjoyed this video, don't forget to smash that button and subscribe to our channel for more awesome programming tutorials. Got any other problems would like to me solve? Drop them comment below and see you in the next one. Bye.